Yep, I am going to get a wire somewhere. Introducing more chaos. So we've obviously got Chaos Hour at the moment, because I'm going to be talking about chaos engineering as well. As Scott explained there, it's not always bad to break the systems that we build. It can be really useful. It helps us understand when systems are going to go wrong, the things that we can do to recover them, and that's what I'm going to be talking today. Now, given that we're talking about chaos, we're going to break some of my questions later, but hopefully you'll get the idea. Anyway, so we're going to start with a little bit of audience participation. This is either going to go really well or really badly. So please try and help out. First question, who here writes code? Either applications, infrastructure as code? Yep, most of us. Good. That's the start I wanted. And who here also thinks about tests? Unit tests, all of those kind of things. Great. That's it. That's all I need from you at this point, except possibly questions at the end. So I'm going to argue that testing it's part of our job. But it's not just part of our job, it's who we are. I think it's integral in us as humans. It's part of our DNA. If you think back to those poor guys and women and families in caves, we were trying to light fires, we were trying different types of wood, seeing what worked better, trying different approaches. So, as I say, testing is built into us. And it's definitely a large part of my job, which I'll come back to in a moment. So, before I do that, very quick introduction. So, my name is Simon Hanmer. There's a very bright light. I work for a company called Global Logic, which is part of Hitachi. We are AWS partners. We work with large enterprises. I work primarily in financial systems, so banks, insurance companies, people like that. The work that we do is things like migration, modernization. But more and more, a large part of the work that we do is helping companies improve their code quality and their deployment quality. How can we get their applications deployed faster and in a better way? And that means a large part of my work is testing. I'm going to have to keep an eye on this because it's gone into order timing. Oops, let's go back. When we work with testing, we've got so many testing approaches that we use. We've got unit tests. Look at the small pieces, our functions. What do the individual pieces of code do? We've got functional testing. Does it work end to end? Does our application or our system work as a whole? We've got integration testing. So maybe we're writing APIs or using APIs. Can all of these pieces talk together, communicate, and do they function as a whole? And testing's so important that we even have development processes built around testing, test-driven development, where hopefully, if we're doing it properly, we write our tests first before we write any code. But there's something missing from all of that. And if you think about those things you see, those testing approaches, they have something in common. And what they have is they're focusing on the code. All of those things look at how our code works. And as Scott said there, the thing that's missing is where does our code run? What are the systems that it's running on? We haven't got an approach there that we can use to test that. And the missing piece is, obviously, given what we've got, Chaos Hour, is chaos engineering. And, sorry, our slides have gone into a bit of chaos here. If you haven't come across chaos engineering, which I suspect many of you have, this is a fairly famous definition. This is from Netflix. And what they're basically saying is that chaos engineering is how can we test what happens when things go wrong? And how can we do that in a controlled way? And we're going to come back to Netflix shortly. But if you've looked at my talks, as Maria said, I'm going to give a brief history because I think it's interesting to understand how we got to where we are with chaos engineering. And the first kind of reference that we'd recognize as chaos engineering that I can see is this chap, Steve Capps. So he worked at Apple and he was building the early Macintoshes, things like Lisas. Anybody seen a Lisa? Anybody worked with one? Unfortunately, old enough, when I was at the start of career, I worked with them. And he worked in the operating system. So he wrote parts of Mac OS, the early operating system, and some of the applications like Mac, etc. Like PCs, early PCs, these systems didn't have a lot of resources. Low memory, low CPU. And what he noticed was applications would fail a lot. They just weren't very resilient. And what he wanted to do was look for a way that he could test those applications. Now, as I said, he'd been working in the operating system, so he'd learned that there was a way to inject events through code. And by events, things like typing, moving the mouse, moving a window. And he realized that because that was there, he could write scripts that would interact with those hooks. And he wrote the script on Monkey. Monkeys and apes, for some reason, seem to have embedded themselves in chaos engineering. We'll definitely come across them in a moment. But next step, Jesse Robbins. Now, Jesse was working in tech through the dot-com boom and bust, and he got a bit disillusioned with it. So he wanted to do something else. And he went off and he joined the fire service in Seattle. He was really taken with the way that the fire service trained their people. They would obviously start with the simple stuff. How does my equipment work? How do I put hoses together? How does the breathing apparatus work? But once the firefighters had got that basic knowledge, they started to introduce problems. So if you're fighting a fire, what happens if the lights go out? What happens if your radios go down so you can't talk to the rest of the people in the team? Kind of sounds like a network problem. And what they were doing is they were teaching people how to deal with worst case. And if you can deal with worst case and you're confident with that, you can carry on and you can probably deal with real emergencies when they happen. Anyway, he decided, he did that for a couple of years, but he wanted to get back into tech. And in the early 2000s, he joined Amazon. And he got this wonderful job role. Now, it definitely feels like my job role some days, but it will look pretty good on your CV. And what Amazon asked him to do was to come in and think about how you could use, they weren't talking about chaos engineering at this point. They were talking about how can we break things and use that as a learning opportunity. So he came up with this idea of game days. And what you would have is you'd have your teams of developers and your ops teams. They were the people who knew how the system worked. And you'd have an opposing team who would break things. So maybe they'd just pull a network cable out or unplug a server, or they would run a script that used all the CPU. And the idea was that they would do that so that the application developers could look at how their systems reacted without knowing what was going to happen in advance. It was how can you simulate when things really go wrong? The thing that he really took about that is you're not just testing your systems, and Scott touched on this, you're testing your people and your processes as well. How do I do my root cause analysis? How do I do lessons learned? How do I do incident escalation if I haven't fixed this in a certain time? On to the next point. Netflix. I said we'd get back to them. So Netflix are probably the company that most people will think of if you talk about chaos engineering. And that is because in 2011, they published a fairly famous blog post in chaos engineering where they talked about their approaches to how they tested their systems. And what they'd done is they'd started to build a set of tools that could bring and introduce problems in a controlled way. So Chaos Monkey is the big one that everybody knows about. It just goes around and turns off servers at random. But as Scott said, they did that in prod. And that brings a mindset to your engineers. If you know that things are going to break at some point, you tend to develop a mindset where you think about your resilience, your recovery. What do you do when things go wrong? And they took those tools and they expanded on them, and we ended up with things like Chaos Janitor and Chaos Monkey and Chaos Gorilla, which simulated an entire cloud availability zone failing. So that was really good. They open sourced those tools. Lots of people started using them. But that means that you have to have resources that think about those tools. How do I run them? I've got to have hardware to run them on. I need to know how to set those tools up so they work. There's an overhead there because it's not your business. That's not where your knowledge is. And Amazon are famous for trying to solve that problem. If you're doing things that aren't your business, how can we make it easier? I don't work for Amazon, by the way, but they use this phrase, undifferentiated heavy lifting. It's where lots of people are doing the same thing. And it's silly things like backups. So for a long time in AWS, if you wanted to do a backup, you had to work out how to do it yourself. You had to write scripts. AWS went, everybody's doing that, so we'll run a service. What they wanted to do, though, sorry, it's getting a little ahead of me, is bring chaos engineering as a service. How can we let people do this without having to build the resources, the toolkits, just the knowledge of what it is that you want to do? They introduced the fault injection simulator as it was first called, and they later renamed that to the fault injection service. And since 2021, FIS has continued to evolve, and we're using it with our clients now. There's a large bank not very far away from here that are using it to test something very similar to Chaos Gorilla. What happens if we lose our networks? Since then, it's continued to evolve. They brought more capabilities in it, and reInvent, their big tech conference last year, they introduced now that you can test Lambda tests. That is an interesting approach, and I'm going to explain why. I'm going to focus on FIS and Lambdas for the rest of this. So a different approach to doing serverless. So how does FIS work? It's based on these things called experiment templates. I think Scott used this idea of experiments as well. He talked about them there. Experiment templates have a number of components. So you have your targets. What do I want to test? My servers, my databases, my network connections. Actions are, what do I want to do to them? Do I want to slow them down? Do I want to kill a pod? Do I want to introduce latency into the network? All of those kind of things. And we have a set of other components in there as well. So anybody who's worked with AWS is not going to be surprised to hear that we have roles. Roles describe the permissions. They control what the experiment can do. As I say, we work with large enterprises, financial systems. They're heavily regulated. If we try to run this and we didn't have those controls, we'd have some problems. We're not going to get very far. We're not going to get a lot of adoption. Having those roles that control what that template does gives our management teams some confidence in knowing what can happen. We can also set alarms. So monitor our metrics, things like the latency of our websites, how fast are our servers running, what is CPU usage, things like that. If it exceeds a certain point, we can stop the experiment. So again, it's giving confidence to our management that this experiment isn't going to go awry and to cause impact on things that we don't want it to. And of course, if we're going to run these experiments, especially with regulated industries, we need to show what it is that we've done, what we've targeted, what we did to them, and what the outcomes were. FIS will capture that in logs, and it can actually now as well, it will generate reports for you. So it will take those, it will take, if you've got dashboards that will show your observability, it can pull those into the report as well. So I mentioned we were going to look at Lambdas, and there's an interesting reason for that. Anybody who's worked with AWS and Lambdas, before we had them, we'd just run code on servers. Building a server means you've got to think about OS, you've got to keep it patched. What packages do I need to install to go along with it? Which users do I give access? It's a real pain. The idea behind Lambdas was that we just run our code. We don't care too much about what it's running on. We care about the runtime. Is it Python, Java, these kind of things. But that introduces a problem, because if we can't log into the server to run scripts to do our testing, how do we interact with them? So what FIS does is it puts the wrapper around the code. So this is code that AWS provide for us. We just tell it to run it. And basically what the wrapper does is it sits, it talks out to FIS, it says, are there any experiments running at the moment? What are you going to do? And it uses that to modify the runtime. So we do all of these things without changing our code. Now, with Lambda, at the moment, we can do three things. We can slow them down. We can either introduce latency, or there's a 15-minute limitation on how long a Lambda can run. So we can actually use that Lambda and cause it to exceed that. You'll get a timeout. If anybody deploys a Lambda, there should be an alarm that tells you, have I had a timeout? That's one of the basic things that you should be monitoring. We can also change the response that we get back from it. HTTP codes, 200 is the response code that we're typically wanting to get. We can change that. And we can introduce a fault. We can tell it that an error has occurred. And with those last two, we can either say, let's introduce the error right at the beginning, or let the code run, because you might want the processing to happen to have an impact on other systems, so you can see what's going to happen. Okay, So, a demo. I'm not as brave. This is a pre-recorded one. But the QR code there is a GitHub repository. So some CloudFormation, some Python code. If you actually want to test this, you can deploy it and you can run it yourself. It should hopefully look something like this. Now, I was going to do the one about introducing latency. I'm very glad I didn't now, because we've seen that. What I've done is I've set up a couple of Lambda functions here. You'll see the bottom one is a function with FIS. So let me show you what that looks like in terms of how we configure it. I mentioned that layer, that wrapper of code. So you can see down at the bottom, we've got the code. AWS provide that. We just need to install it alongside our Lambda. If you come back up and look at the configuration, what I'm going to show you is I've added a tag. So AWS has tags, little bits of labels we can put on our infrastructure. I'm adding one, FIS demo is true. And I'll come back to why that's there in a minute. Okay, scroll up and find my code. I'm not a developer, so this is the easiest code in the world. All it does is it lists the storage buckets in my account and gives the names out. So I'm going to run that. Now, obviously, we're doing this from the console. It's just a demo. We obviously deploy this through infrastructure code. We test against our real systems, but this is just a quick way of showing it. So when it runs, if everything's going to go to plan, HTTP code 200, everything's good, tells me everything is okay. If I carry on down, I can see my logs, and you'll notice that some of that text is red. That's the text that's coming from the wrapper. That's good. It tells me it's properly configured, the wrapper's running. But it also tells me down at the bottom, no active faults. There are no templates running at the moment. Nothing that's going to interact with this Lambda. And then we've just got the output. It's just showing the names of the buckets, as I say. Just blurred the account numbers. So let's have a look at how FIS works now. So in the console, we'll come through to FIS. We're going to create a template. So let's say templates are these things that we use to define what we want. I'm going to put a description, injecting an HTTP response, a name, and down at the bottom, we can either target just the account that we're in, or we can target multiple accounts. So if you've got a properly set up system with different resources and different accounts, we could do that as well. But this is just a simple one. Okay, so I mentioned actions and targets. We start by defining the action. Again, a name and a description. Just let my typing catch up. Now, action type is, what is it do I want to test? Is it an EC2? Is it an RDS database? Is it my network? We're talking about Lambda, so you'll not be surprised in a moment we pick that. And then we choose what is it do I want to do to the Lambdas. In this case, inject a response code. You'll get different parameters there depending on what you choose. But it puts a placeholder in for the targets, which we'll come to in a minute, the things we want to test. And in this case, I need to tell it what response I'm going to return. It's just going to be JSON. I want this to run for 5 minutes, this step. And I want it to target 100% of the Lambdas that it finds. So I could say just target 50% or 10%. And I'm going to say run to completion and return 418. There's a little in-joke there for HTTP, if people know their codes. If not, come and see me after. We'll save that. We get a summary there of what it is we're trying to do. And it goes into the targets. Targets are what we want to test now. Now, I could just say, show me all the Lambdas, and I'll choose one of those. But it's more useful to run queries and parameter filtering. So what I'm going to say is, look for that tag that I put on the Lambda. Find any Lambdas that have that tag, and those are what we're going to target. Okay, that's pretty much. I could add more actions and targets. We can obviously build more and more complex things in here. But if I come down and I click through, I've skipped a few steps there just in terms of defining the role, etc. We'll create that, and we get a nice summary here of what the experiment's doing. And this is where we'd come to if we want to run the experiment. So we can see the actions. It's telling me I'm going to inject an HTTP response. This action is going to run for 5 minutes. It will tell me the targets. Not surprisingly, it's going to be a Lambda function. But if I run a preview, it will actually look at the account and it will tell me the things that it can find now that are likely to be affected. So you'll see there that test function with FIS that we set up. Okay. Other things that we can do, if we go to timeline, if we've got multiple steps, it will tell us how long each one's going to run for, how long the experiment in total will run, so we can get a good overview. And we can set schedules. So if you want to annoy everybody, get this to run at 8 o'clock on a Friday morning, just before everybody's trying to go home. Okay, so save that, and we'll kick off a start. Just watching my time here. Okay, And that experiment is now running. So you'll see it's initializing. In a moment, it'll switch to running. So that experiment that is there now. So switch back to my Lambda that I set up. Now, I've not changed any code. Honestly, I haven't cheated. If you take this and run it yourself, you can see that. All I'm going to do is restart that Lambda that we ran before. So it's come up. We're going to get the red text again, show us the logs, the information coming back from FIS. Sorry, it's given us that response code, the one that we told it, 418. So it's changed how our Lambda responds without changing the code in any way. We've got the log information there. You'll see that of the one it's found an active fault, there is an experiment running that is changing. So this is what I mean about it all going into the logs, so we can capture this later. Okay, and it tells us what it is that it's done. It modified the response. So that was just a really simple demo to show you how FIS works at a high level. Hopefully it gives you an idea. But it's great being able to run those experiments, but there are some things that we have to think about. So don't forget, Scott touched on this. Everything fails eventually. Yeah, it comes up. If you go to a conference with AWS, somebody at some point will say that. What they always forget to say is the bit that comes after, which is if you know it's going to fail, plan for when it goes wrong. And think about how you can design your systems to cope with that. And it isn't just, how do I get my system to come back up quickly? It's how, told you my slides are playing up, so sorry. How do you recover from that? So there was a big outage recently, which was Google. And they fixed it reasonably quickly. I think it was something to do with their equivalent of IAM. But it took them a really long time to get the system up. And that's because every time they fixed it, it would get hammered with requests from people trying to use it. So when you build your systems, think about how you recover. Don't just hammer your APIs. Give it some back off. Try a second, 5 seconds, 10 seconds. Build randomness into when you do those things so not everybody hits your systems at the same time. As I said, and Scott touched on this as well, chaos engineering isn't just about your systems and your applications. It's how you test your people, your processes. You can use this as a testing tool. If you've got people who are starting in your operations management team, best way, start them in this. You can get it in a controlled way. And finally, just to touch on, FIS only knows about your infrastructure. It knows nothing about your applications. You have that knowledge. So use the templates, but you still need to do your testing to see how your system is impacted at that point. So just be aware of that limitation. But with that, as I say, we haven't got time for questions, but I am around for the rest of the day, so feel free to come and grab me. The QR code there is my LinkedIn profile, so feel free to reach out again. And thank you very much for your time today. Hope you enjoy that. Enjoy the rest of the day. Thanks.